Now I see that Ritesh has joined us. Hi, Ritesh. Ritesh Ratti has 13 plus years of professional experience in the area of applied machine learning and data science. Ritesh Ratti is currently working as a senior data scientist in Hellofresh.
Yeah,
Wonderful. I've used your services many times, and my son is also an avid user of your services too,
yeah,
Ritesh.
yeah. Nice
So
to
I'm
hear
sure
that.
you have.
Nice to hear that too. Yeah. Can you hear me? Okay. Can you hear me well?
Yeah,
I think we lost Elliot. Yeah.
yeah.
Uh, but anyways, let me.
I see that you're doing large language modeling, and your presentation today will be unsupervised machine learning based methods for network intrusion detection system. So
That's right.
please, Ritesh, go ahead.
Yeah, sure. Let me share my screen. So I'll be talking today more on like what are the ways, unsupervised ways to detect an attack over the networking data. So this talk is more aligned to the technical concepts that we have in unsupervised, why we need the unsupervised mechanism to for the attack detection itself. So let's start from the beginning. Okay, so unsupervised learning methods for network intrusion detection. So that is the topic for today's talk, and this is the agenda. First, I will be talking about what the intrusion detection system means, and what how the basically network security holes loopholes are attacked by various attackers, and what are the various attacks that have been performed at various network TCP/IP layers, and why we need the intrusion detection system to do that. And mostly intrusion detection systems have been traditionally built by rule-based mechanisms. So why we need machine learning approach to solve the IDS problem, and what are the available data set, types of data set, what features we need to take care on when building IDS solutions. And we also talk about next what the meaning of supervised versus unsupervised methods, why we need unsupervised specifically, and some of the unsupervised learning based models that are state of the art models for unsupervised network attack detection. We will discuss on that as well. Okay, starting from introduction to network security, it's a sub branch of cyber security. The bigger branch is information security, and as we know, like cybercrime is expected to skyrocket in coming years, and overall estimated cost by 2025 is around $17.65 trillion. So there's a huge opportunity of building security-based solutions by utilizing the state-of-the-art machine learning technologies over the years. So this is the statistical report that has been showing up, which suggests like the cost has been increased, is increasing exponentially over the years. So whenever an attack occurs, what are the various phases for intrusion or attack? So these are some of the things that attacker normally do. So they first get the details on the let's say, target specific machines or the environment that the machines are working on. So reconnaissance is the first step. Then on the weaponization, they try to access those remote machines by utilizing some payload or sending some malicious files over the network. Once these files are delivered, then exploitation phase comes up wherein they used to trigger a couple of code using vulnerabilities that have been existing in those application or system, and install their various different weapons like which are work as a backdoor on the target system, which will now allow access to multiple other system as well, which ultimately drill down to command and controlling of the whole network, target network. And later on, the various attacks can be performed like the stealing of files or information from the data itself, executing couple of SQL commands. So these are some of the things that attackers usually perform during these multiple phases. When we talk about various attacks at TCP/IP layer, we have defined in TCP/IP layers various infrastructure depending upon five different layers. So application layer, we have seen like flooding is a major attack. We have SQL injection attack. At the transport layer, we have SYN UDP flood or man in the middle attack, which is specifically at the transport or TCP UDP protocol vulnerabilities at networking layer. We have ICMP flood, wherein attacker sends the ICMP echo request messages in abundance, and then that perform the connection break or the distributed denial of service attack. In data link layer, similarly, we have the forged frames the, build up to send to an attacker machine, and in physical layer, we have jamming or signal jamming as a main attack. Now, where these are various tools that people or the attacker uses normally to perform the attacks, like Ncrack, Cain enable John the Ripper is basically for performing the brute force kind of attack. Nmap is vulnerability set scanner. LOIC and HOIC are basically tools for to perform the DDoS attacks over the network. So we talk about a lot of attacks. Now, what's the mechanism? So there are a couple of methods, like we know about firewall, but these are very static one, and then it requires to be updated. So what are the other options? Intrusion detection is a method wherein which is able to identify a set of malicious actions that compromise the integrity and availability of information resources. Now, to develop those detection systems which are only detecting the attack and generating the alerts for us, and administrator has to take care on these different alerts specifically. So the challenges are again the accuracy of those systems. I mean, with less false alarms, the system has to generate the alert, the detection speed, at what speed we are able to capture those attacks, because it is able, if it is able to perform the detection on the based on the incoming network packets or the speed of the network, it is well and good. What are the dynamic nature of attacks? Because attacks have been evolving a lot day by day. New attack is coming up, so intuition detection systems have to be cater these new changes inherently so that they can identify the new attacks as well. So as per the types, we know these are some of the types, like signature based versus anomaly based. Signature based usually work based on the predefined rules, and anomaly based ideas uh, uh, estimate how if the anomaly has been occurred by looking into the distribution of the data or the network packets and generate an alert. Now, in terms of placement, it can be of two types: host-based versus network-based, like where it is going to be placed at specific host or one IDS for a whole network. So these are some of the information on intrusion detection system. Now, to develop them in using machine learning based techniques, there are a couple of ways. Like what we do is we follow a general pattern of solving machine learning problems. We define the problem. We collect the data from multiple sources, which is basically the network packets that we collect from our network. Prepare the data, label it, or use then perform the model training itself, wherein utilizing the labels we are estimating the model specific metrics, and then evaluate the model on the live environment, deploy and further improve. So this is an iterative process which machine learning pipeline allow us to perform and build the IDS solution. To use that, we need to have various data sets available. So these are some of the research data that has been developed over the years. DARPA was the first data set developed by MIT Lincoln Laboratory, and KDT Cup 99 was also quite famous during that time. But since the new attack has been come up and the properties of network also has changed, so the recent data set, which are CIC IDS 2018, which is recently developed by Canadian Institute of Cybersecurity, and CIC DDoS, which is specifically for DDoS attack detection. So we so what we do is to develop a POC, we utilize these data sets, and these data sets consist of two formats: one on the CSV files wherein the labeling information is available, and another is on the network packets, like captured or over the different networks on which various attacks have been performed. So these are some of the data sets which people utilize. Now the type of data as I talk about, it consists in two forms, one at packet level and another at flow level. So what we do is, like, packet level detection consists of capturing packet level information from network packets and generate the label data based on attack timing. And then it consists of features like what's the header information. As you see on the right, there are L2, L3, L4. These are various headers associated with one network packet, and these information are getting transformed in terms of raw data files. So these features have been constituted and people perform deep packet inspection on these encrypted networks. Now, flow level data is on the other hand, what it uses is capture those packet and with specific time window generate the various flow information. So this flow information consists of features like how many bytes have been transferred per second, number of packets processed, what is the flow, inter-arrival time, etc. So on the right side, you can see the NetFlow enabled device, which is capturing the flow level information. And we can use this specific flow level information to build the machine learning models as well. So this in terms of data, these are the two types. And when we talk about machine learning based ideas, obviously there are a couple of mechanisms. So unsupervised is one of them where we don't require any label data. And some of the models are defined here. In supervised, we have label information. So what we can build up is with using this label information and the features, we can develop the neural network based infrastructure to build machine learning based methods. And hybrid is combining the both the things together in one system. So supervised learning based methods, they generally use the methods such as classifiers or signature matching or regression based models that consider building the models using labeled network traffic data. And these labeled traffic data is coming from the source of information where we have identified couple of attacks, like at what timing it occurred, and then during that what kind of PCAP or the captured packet information was converted to flow and then prepare a data set. And once this is done, like we can build classification based models, like decision tree is one of them, SVM neural network, or we can also build signature based methods like snort and bro are quite famous signature based ideas which are very familiar in nature, and then we can define the rules there which are able to detect the attack. In regression-based methods, there are linear and polynomial regression which can use this information and build supervised modeling. So this talk is mainly concentrated on unsupervised. So let's talk about that. In some unsupervised learning-based model, what ideas models is it benign the behavior of system from the normal profile and then see if there is any deviation occur from the known profile. So that is a deviation wherein we call that intrusion or attack happened. So clustering is one of the option. As you see on the figure, there are three clusters build up, and one is outlier, which is very far from the distant on the cluster side. Outlier detection is also one of the methods, and on the statistical methods, we see like over the time how the value of particular parameter changes. So if you see on the right, anomaly occurred because there is a huge deviation from the value. So these are some of the approaches people generally used, and deep learning based models also can be utilized to solve that. Now, when we compare the two approaches, we need to see like what are the major benefit of unsupervised methods. So supervised learning, so they require label data in abundance, and these label data has to be updated frequently to capture the new attacks. So this is the major limitation of supervised learning mechanism, which unsupervised learning solves because they don't require any label data to build a model. It can capture the new attacks and the zero-day attacks as well. And because it is ultimately trying to capture the deviation and doesn't require the frequent updates of the data set itself. So once we have the raw data, we can utilize that to build the unsupervised learning based model. So that is the beauty of unsupervised mechanism. On the downside, it really have high false alarms, which ultimately we need to reduce by manual lookup or by relabeling the data. So that is a one major draw. So let's talk about unsupervised learning based methods in detail. What are the couple of mechanisms that people can opt for? So clustering-based methods is one that I talk about, which ultimately tries to group similar instances into cluster and identify the anomalous points or the set of points based on different factors, maybe the size, distance, or density. On the right, the distance has been taken into account. And on terms of density, we can also see like some clusters are very highly dense and some other cluster which are very less dense. So that could be one anomaly. In terms of size of the cluster, maybe the normal cluster is having so many points, but but a cluster with attack data is having very less points, which is lying too distant apart from it. So these are some of the features that people use, and these clustering techniques like centroid-based, where k-means clustering is famous. In terms of density-based, DB-scan clustering is basically used to perform density-based evaluation. Then connectivity-based, we have a birch clustering, wherein we generate the hierarchical clustering information out of the network features that we expected earlier. So these are clustering-based methods. Now, in terms of outlier detection-based methods, we can see there can be a various outlier. Like outliers could be 1 point, or could be a set of points, like collective outlier. We call it collective outlier, or it could be a global outlier in terms of data itself. On the red side, all the red dots, they are shown as an outlier. So outlier detection can also be uh, utilized for identifying anomalies, one class SVM, isolation forest, and clustering based local outlier factor. So these are some of the algorithms that people use in normally to find the outlier in the data itself. So third is statistical machine learning based method, wherein we try to capture the statistical information from the identification of different features, like what is the standard deviation for particular feature, and build up the normal statistical profile in terms of the features, and then estimate how much deviation from the normal has been performed when the attack occurred. So if it is more than the predefined threshold, then we called it as an attack. So this threshold is again needs to be adjusted by administrator by looking into the behavior of the network that they are working on. So the features like number of packets transmitted or high frequency usage of certain IP address and ports, the frequent changes in TCP flags. So this can be measured very well in by looking into statistical machine learning based methods. Okay, another very popular method these days are deep learning based method, wherein we are utilizing deep learning models for unsupervised detection, and autoencoder and generative adversarial network are some of them. So in autoencoder, what we try to build up is like we are trying to encode the incoming information, and from the decoder side, we are trying to regenerate the same input. So what we do is like we train this autoencoder on the normal data, on the normal packet captures, and try to estimate the reconstruction error. So if this reconstruction error is very high, then we tell that some attack has been occurred. So there are two ways wherein this autoencoder can be utilized. So one way is like reconstruction error based, where is autoencoder learn the representation for the normal traffic, and execution time it predicts whether attack occurred or not by estimating the reconstruction error and comparing with the threshold. And the second way where it can be utilized is triplet loss based, wherein we learn the representation for two encoders, specifically one for attack set and one for normal set. And then once these encoders are trained, we estimate the triplet loss function for attack identification. So this is the loss function wherein we are trying to compare the various pairs that we have. And this is one of the basic or the well-known models which is being utilized in autoencoder based intrusion detection method. There are some of other flavors of autoencoder like variational autoencoder, which is quite popular these days to build an ID system.
But
Then,
Ritesh, is
yeah.
this more like an on-premise solution? Is this a cloud type of architecture? That hasn't really been defined.
Yeah, so this architecture actually we used to define. What we define is like we define two things, encoder and decoder, in terms of deep learning based model. And then
Yeah.
whatever input is coming to encoder, we are trying to regenerate the input from the decoder side. So we suppose one part on the normal side, we have the estimated these network various parameters. Now, when the attack data comes up, it will be re-estimating, but will regenerate with the high reconstruction error. So that is one of the mechanism people use in autoencoder side. So
Okay.
reconstruction error is a major criteria here.
Thank you. Thank you. Do you have many more slides, Ritesh?
Only one, yeah. So generative adversarial network is one more method, which is basically uh, train the model by learning the data distribution and represent it at latent variables. So two part it is having. One is generative network and discriminator network. So in generator network, we introduce some kind of random noise and trying to discriminate it with the real data. So generator and discriminator are trained together. And what we do is like the generative training objective is to increase the error rate of the discriminator network. Like discriminator is trying to find out the discrimination between the real and the fake data. So these two models are getting trained all together. So the major implication or of this concept is to build up the utilizing oversampling, because attack data is very less in nature. So what we do is like we utilize malicious the normal data and then try to introduce random noise, assuming it as a malicious packet, and then utilize this kind of oversampling in GAN based models. So these are some of the
Good engineering. Yeah.
that's right. So these two are very well-known models for building unsupervised solutions. Yeah. So that's with this, I think I covered a couple of modeling and methods and convey this information. Yeah. Thank you. I would be open
In
to
your in
have
your
any.
13 years experience, though, there must have been a lot of changes that have happened, a lot of
Yeah, that's right.
evolutions, shall we say. What's the biggest evolution that's happened considering AI now that
Yeah.
people are using automated
So yeah, that's right.
systems?
Yeah. So I think so. Initially, if you think of like after 2000 to 2015 method, which was quite rule based, like I defined a rule wherein the number of incoming packets or number of ICMP equal replies is greater than some threshold, then I will be executing at an attack. So IP tables or snot rules did come up, and then things got evolved within the machine learning or supervised learning based mechanisms were quite popular, wherein people were trying to label the data based on the specific attack type, and then building a model, supervised model. And then the new era comes up wherein unsupervised modeling has started coming into picture, like transformer based model or the deep learning based model, which I talk about, autoencoder based models. So which don't require any label data to train with. So that is the beauty of these mechanisms. And uh, the major challenges now people are facing, how we can reduce this false alarm. So there are a couple of techniques people are trying to incorporate on the self-supervised learning, or the uh, or mechanism related to active learning. So these are quite popular now these days as well. So these are some of the transformations that I have seen over the past few years. Yeah.
Very interesting. Thank you, Ritesh. Thank you very much indeed.
Yeah. Thank you. I will be open to any question if you have. Yeah. And obviously you can reach me on LinkedIn or any specific source of channels. Yeah. Thank you.
Thank you, Ritesh.